Hi guys, so today we're going to be talking about trapezoids. So let's start with some definitions first. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. These parallel sides are known as bases. So this is an example of a trapezoid. Note that it only has one pair of parallel sides. These two parallel sides, A, B, and DC, are known as the bases. Okay. There are two pairs of base angles that's formed by one of the base and the legs. So an example is angle C and D here are base angles. The non-parallel sides are known as the legs. And if these legs are congruent, then it's a special type of trapezoid known as an isosceles trapezoid. In most of your experience with trapezoids, they were probably isosceles trapezoids. So what we know specially about isosceles trapezoids is that each pair of the base angles are congruent. So angle A here and angle B are congruent, and angle C and angle D here are congruent. What we also know is that the diagonals of an isosceles trapezoid are congruent. So that's very similar to our rectangle here. Right? And so that's why we know that AC is congruent to BD. Okay? So we're going to start with example 1 by proving that the diagonals of an isosceles trapezoid are congruent, and we're going to do so by writing a flow proof. Right? So what we know is MNOP is an isosceles trapezoid. We are going to prove that MO and NP are congruent. Okay? So I'm going to start off with my given that MNOP is an isosceles trapezoid. So that's my first thing, okay, and that is given to me. Okay, because it's an isosceles trapezoid, what I know is that MP and NO are going to be congruent. That's one of the things I know. MP is congruent to NO. That is going to be due to the definition of isosceles trapezoid. Definition of isosceles trapezoid. Right. Also, because it's an isosceles trapezoid, the base angles are going to be congruent. So let me just mark. So MP congruent to NO. Okay, and then I also know that the base angles are going to be congruent. So MPO is congruent to NOP. So angle MPO is congruent to angle NOP. And then the reason for that is because base angles of isosceles trapezoids are congruent. Trapezoid are congruent. Okay, so I'm just going to mark that in my picture here. So what that means is this angle here is congruent to this angle here. Okay. That also flows from that isosceles trapezoid thing. And then another thing I know is that PO is congruent to PO. So PO congruent to itself. That is the reflexive property that does not come from the given part, at least. So this reflexive property. Okay. So that means this. Okay, and then from these three things, I can prove that this triangle here is congruent to this triangle here. So all three of these things tell me that triangle MPO is congruent to triangle NOP, and that comes from side angle side congruence postulate. Okay. And then, so if these triangles are congruent, that means this has to be congruent to this. So from here, MO has to be congruent to NP, and that is due to CPCTC. Corresponding parts of congruent triangles have to be congruent. So if these two triangles are congruent, this part has to be congruent to this part. And there you go. Okay. So why don't you try CYP1? You're going to write a proof. It says theorem 6.18. That says each pair of base angles of an isosceles trapezoid are congruent. So write a proof for that. It could be paragraph proof or any. Okay, your proof should go something like this. So I just started off with the picture. So we know that we have an isosceles trapezoid. I called it ABCD. So BC and AD are parallel. Definition of a trapezoid, there's one pair of parallel sides. And then because it's an isosceles trapezoid, that means the legs are congruent. So that's why AB and CD here are congruent. Okay. And we're trying to prove that the base angles are congruent. Okay, so first what we did is we draw auxiliary segments. So that way BF here is perpendicular to this base line here, and CE is also parallel to this baseline here. Okay. Since BC and AD are parallel, and we know that parallel lines are everywhere equidistant, that means BF and CE have to be congruent. Okay. We know perpendicular lines form right angles, so this angle here, angle BFA, and angle CED here are right angles. As a result, this is a right triangle. That's the definition of right triangle, that has one right angle, right? So because of this right angle and this right angle, these are right triangles. Okay? Which means that I can use the hypotenuse leg theorem since the legs are congruent, one leg, and then the hypotenuse is congruent. I can prove that these triangles are congruent using the hypotenuse leg theorem. Okay? As a result, then, angle A has to be congruent to angle D because of CPCTC. Corresponding parts of congruent triangles have to be congruent. Okay. Then, since CBF and BCE, so this one here and this one here are right angles, okay, and all right angles are congruent, then we know that angle CBF and angle BCE are congruent. These two angles are congruent. Okay, we also know that this part here, this angle of this triangle and this angle of this triangle have to be congruent because of the congruent triangles. Corresponding parts of congruent triangles are congruent. So as a result, when I add these two together and add these two together, they are also congruent by angle addition. Since if these two are the same and these two are the same, when I add this and this and this and this, they should be equal. And there you go. We're going to skip example 2 because it's not really a great example, and we're going to move on to example 3. Okay. So we have a quadrilateral here, JKLM. It has these vertices, J at negative 18, negative 1, K at negative 6, 8, L at 18, 1, and M at negative 18, negative 26. We're going to verify that JKLM is a trapezoid, and how we're going to do that is we're going to find one pair of parallel lines. Okay, so based on how it's named, that's how it's connected. So let's find JK. So JK here, the slope, okay, it's going to be rise over 1, so 8 minus negative 1, and then negative 6 minus 18, minus negative 18. Right? So 8 minus negative 1 is 9. Negative 6 minus negative 18, so that's plus 18. That will be 12, so this is 3/4. Okay. So then next will be KL, so slope of KL. Rise over 1, so 1 minus 8 over 18 minus negative 6. 1 minus 8 is 7. 18 minus negative 6 is 24. Okay. Then I'm going to do LM. So rise over 1, so negative 26 minus 1, and then negative 18 minus 18. Okay, so this gives me negative 27, and negative 18 minus 18 is negative 36, so this becomes 27 over 36, both divisible by negative 9, so this becomes 3/4. So right now I know that JK and LM are parallel. They have one pair, they have the same slope. Okay. So then I just need to check MJ. So slope of MJ. So negative 26 minus negative 1. And negative 18 minus negative 18. This gives me negative 25 over 0. This is undefined, and since I only have one pair of parallel lines, then it is a trapezoid. So since JK is parallel to LM, and KL and MJ are not parallel to each other, that makes this a trapezoid, since there's only one pair of parallel lines. It is a trapezoid. Okay. So the next part, we're going to determine whether JKLM is an isosceles trapezoid. In order to be an isosceles trapezoid, the non-parallel sides, so KL and MJ, have to be congruent. Okay, so let's find the distance of those. I'm going to switch pens here. So KL, let's find their distance. So square root of negative 6 minus 18 squared plus 8 minus 1 squared. Negative 6 minus 18 is negative 24. 8 minus 1 is 7. Negative 24 squared is 576. So 576 plus 7 squared is 49. This gives me square root of 625. Square root of 625 is 25. So KL is 25 units long. Okay. So now let's find MJ. So negative 18 minus negative 18 squared plus negative 1 minus negative 26 squared. So this becomes 0 squared. This negative 1 minus becomes 25 squared. So this is 25 squared. Square root of 25 squared is 25. Okay, and so since they are congruent, the legs, so the non-parallel sides, because the non-parallel sides, which are known as the legs, are congruent, this is an isosceles trapezoid. So, since the legs are congruent, JKLM is an isosceles trapezoid. Okay, so why don't you try CYP3, and then once you're done, come check your answer. Okay, this is what you should have gotten. So because QR is parallel to ST, but RS and QT are not parallel, there's only one pair of parallel sides that makes QRST a trapezoid. However, it is not an isosceles trapezoid because RS is 6 and QT is 2 square root of 10 for its length. And so because these legs are not congruent, it is not an isosceles trapezoid. Okay, so then our last example is for median of a trapezoid. So let's look at the definition of median. We saw medians for triangles before, but this time this is a median of a trapezoid. And the median of a trapezoid is the segment that joins the midpoints of the legs of a trapezoid. Okay? What we know is it's actually parallel to and it's equidistant from each base. Right? So this is going the same direction. Has the same slope, if we can think about it that way, as our bases, and then it's equidistant from each of the bases. Right? And then another thing we learned is that the median of a trapezoid, not only is it parallel to the bases, its measure is 1/2 the sum of the measures of the bases. So our median here is EF. EF is half of the distance of AB plus DC, my two bases combined. Right? So with that information, we're going to do example 4 here. Right? So in the diagram here, QRST represents an outdoor eating area that's in the shape of an isosceles trapezoid. The median XY here represents the sidewalk through the area. Okay. We want to find what TS is if QR is 22 and XY is 15. So let me just label that here. So we know that QR is 22, XY is 15, and we do not know what TS is. Okay. So based on that theorem about the median of a trapezoid, what we know is that XY is half of QR plus TS. Okay. That's what that theorem told us, that the median is half of the sum of the two bases. Right, so I'm going to fill in what I know. I know XY is 15. I know QR is 22. And I'm just going to put X as my TS. Right? So I'm going to get rid of the 1/2 by multiplying 2 on both sides. That gives me 30 equals 22 plus X. Subtract 22 on both sides, 8 equals X. So TS has a length of 8 units long. Okay, then let's look at B. So B wants us to find what measure of angle 1, measure of angle 2, measure of angle 3, and measure of angle 4 is. So we know that measure of angle 1 here is 4a minus 10. Measure of angle 3 here is 3a plus 32.5. Right? So we know that angle 1 and 3 are supplementary, angle 2 and 4 are supplementary. We know that these are the same and these are the same. So what we're going to do is we're going to set measure of angle 1 plus the measure of angle 3 equals 180. Okay. Substituted in for what I know, measure of angle 1 is 4a minus 10. Measure of angle 3 is 3a plus 32.5. Okay. I'm going to combine like terms. 4a plus 3a is 7a. Negative 10 plus 32.5 is 22.5. We're going to subtract the 22.5 on both sides. And that gives me 157.5. So 7a equals 157.5. Divide both sides by 7, and that gives me 22.5. Right? Then I'm going to plug it in. So if measure of angle 1 is 4a minus 10, plug in 22.5 for a. 4 times 22.5 is 90. This is 90 minus 10, so that means it's 80. Okay. If measure of angle 1 is 80, measure of angle 2 is the same because it's an isosceles trapezoid, so base angles are congruent. Okay. Then here, I know that measure of angle 3 should be 100, but just to make sure that I did the math correctly, I'm going to still plug it in to check. Right. 3 times 22.5 is 67.5 plus 32.5, and that gives me my 100. So measure of angle 3 is 100 degrees, and 4 as its other base angle should also be 100 degrees. And there you go. Okay. So why don't you try CYP 4A and 4B on your own, and then come check your answer when you're done. Okay, so for 4A, you should have gotten RP equals 15. And for 4B, measure of angle L is 42, measure of angle M is 42, measure of angle J is 138, and measure of angle K is 138. If you got that, you can skip ahead to the construction section, or you can get started on your homework. Okay? If not, here's your explanation. So 4A, I just kind of roughly drew it. I didn't know what it looked like. I didn't know which side was bigger. Okay, but with the median RP, we know that RP, the median, is half of the sum of the two bases. That's why. Then I substituted RP for 5 plus x. I substituted JK for 2 times the quantity of x plus 3. And I substituted ML with 1/2 x minus 1. Okay? I got rid of the half by multiplying by 2 on both sides. That's why you see here that it's 10 plus 2x, and the half is gone here. Then I distributed the 2 here, so that's 2x plus 6 plus 1/2 x minus 1. Here, since they have 2x on both sides, I could get rid of that, leaving me with just 10 on the left side, and then on the right side, just with 1/2 x, and 6 minus 1 is 5. Okay. Then I subtracted 5 on both sides, so that gives me 5 equals 1/2 x. Got rid of the 1/2 by multiplying by 2, so that gives me 10 equals x. And since RP is 5 plus x, I can now substitute 10 in for x, so RP is 15. Okay. And then for 4b, find the measure of each base angle of JKLM if measure of angle L equals x, and measure of angle J is 3x plus 12. So what I know is that JK is the same and ML is the same. JM here are supplementary, KL is supplementary, so that means JL has to be supplementary, which is why measure of angle L plus the measure of angle J is going to be equal 180. Right, so substitute it in, x for angle L and 3x plus 12 for J. X plus 3x is 4x. Subtract 12 on both sides, that gives me 168. Divide 4 on both sides, x equals 40. So since angle L is 42. Since angle L is just x, that means angle L is 42. The base angle that goes with that is angle M, so that's also 42. Angle J, plugged in the 42, 3 times 42 is 126, plus 12 is 138, so angle J is 138, and its pair is with angle K, so angle K is 138 as well. Okay, so the next part is optional for constructions. It's how do we construct the median of a trapezoid. So I didn't draw any trapezoids, that's my mistake. So let me draw some trapezoids first. So definition of a trapezoid, it has one pair of parallel lines. So I want to make sure that my thing is parallel. Okay, so it's this side, and then let's do this side. Right. So these are parallel. And then let me just connect it here. So this is not an isosceles trapezoid because the legs are not congruent. Okay. So let's construct the median of this trapezoid. What we're basically going to do is we're going to find the perpendicular bisector because that will give us, it'll bisect the segment for us. And then we'll just connect those midpoints. Okay. So to do the bisector, we open our thing slightly more than half. Okay. Leaving it the same, go to the other side, slightly more than half. Okay. So this, when I connect, will give me my middle point. So here. And so this here is the middle. Okay. So this is the midpoint. Okay. I'm going to do the same thing here for this leg. So open my compass to more than half, make my arcs. Okay. Go to the other side of that segment, make my arcs. Okay. And then when I connect this, this would be the perpendicular bisector, but really I just need the midpoint, so I don't have to draw the whole line. So then this is the midpoint here for that. And then the median is midpoint to midpoint. And so if this is the middle here, and then this is the middle here, this is the median. There you go. Okay, let's try it one more time. Let's do it for a bigger trapezoid. So we can even do it slanted. Okay, so let's do it slanted. Okay, so let's draw here. Turn down. So here's my trapezoid. This looks like a pretty good isosceles, although I don't think it's exact since I didn't measure. Yep. But again, it's a trapezoid because I have my one pair of parallel lines. Okay. So how I'm going to do the median is I need to find the midpoint of each of the legs. So I'm going to use the perpendicular bisector to get the middle part. So again, how do we do that? We open our compass to slightly more than half of that length. We draw arcs. We go to the other side of the segment, leaving the compass the same, draw those arcs. Okay. So if I then connected this would be the perpendicular bisector, but really I just want the middle part. So this here is the median. So this is equal to this. Okay. Then I'm going to do it the same for the other leg. Open my compass to more than half. Make my arcs. Go to the other side of this segment. Make my arcs. Okay. So if I connect these, that will give me the perpendicular bisector of this other one. So this here is the other midpoint. And then a median is midpoint to midpoint. So if I connect these two midpoints, this is the median. Ooh. And there you go. So that's it for today. Have a great rest of the day. Bye, guys.